Uranus, the seventh planet from the Sun and the coldest in our solar system, is often overlooked, a distant and mysterious ice giant that humans have visited only once. For decades, it has remained in the shadows of space, hiding its secrets beneath a shroud of ice and methane clouds. But now, thanks to groundbreaking new research, Uranus and its moons may be far more fascinating than we ever imagined. What if the icy worlds orbiting Uranus aren't just barren rocks, but worlds teeming with the potential for life? Imagine a planet tilted at such an extreme angle that it almost rolls around the Sun like a barrel. Uranus's unique axial tilt has baffled scientists for centuries, but its magnetosphere, its powerful, invisible shield of energy, has proven to be an even greater enigma. Recent discoveries have revealed that Uranus's magnetic field is not just unusual but more dynamic and unpredictable than previously thought. Its magnetic lines dance in ways that defy our old models, challenging everything we assume about how planetary magnetospheres function. It's as if the planet itself has been waiting for us to finally understand its true magnetic personality. But what makes these findings truly extraordinary is that they don't just apply to Uranus itself. They have far-reaching implications for its moons, and possibly for exoplanets far beyond our solar system. If Uranus's magnetosphere behaves in such an unexpected manner, what does this mean for the worlds that orbit it? Could the extreme electromagnetic forces at play be influencing its moons in ways that make them more habitable than we ever imagined? For decades, Uranus was relegated to the background of planetary science. Unlike Jupiter and Saturn, which have been visited and studied by multiple spacecraft, Uranus has only been briefly examined, once, by NASA's Voyager 2 probe in 1986. That flyby gave us our first close-up look at the ice giant, revealing a strange, pale blue world with an unusual magnetic field and a collection of bizarre moons. But without further exploration, Uranus remained largely a mystery. Now, with the development of advanced computational models and new interpretations of Voyager 2's data, scientists are rewriting everything we thought we knew about this distant world. The latest findings suggest that Uranus's magnetosphere might actually undergo dramatic shifts in response to changes in solar wind conditions. This means that the planet's magnetosphere is not a stable, protective barrier but a fluctuating, dynamic force that could be affecting the habitability of its moons. One of the most astonishing discoveries of recent years came in 2024 when researchers identified what they believe to be a solar wind portal in Uranus's magnetosphere. This phenomenon could explain the unpredictable fluctuations in the planet's magnetic field and its interactions with the solar wind. In essence, Uranus's magnetosphere might not just be shielding the planet, it could be an open gateway allowing solar wind to interact directly with its moons. Why does this matter? Because solar wind carries charged particles that can alter the chemistry of planetary atmospheres and surfaces. If Uranus's moons are exposed to this fluctuating magnetic field, it could mean that they experience a cycle of energetic interactions that might lead to conditions suitable for life, at least in microbial form. This discovery has challenged long-standing theories about magnetospheres across the solar system. Previously, scientists assumed that Uranus, like other gas giants, had a relatively static magnetic field that acted as a consistent barrier against solar wind. But this new model suggests that the magnetic field is an ever-changing force, creating an environment unlike anything we've observed elsewhere. Uranus has at least 27 known moons, many of which are composed of a mix of rock and ice. While some of them, like Miranda and Titania, have long been suspected of having subsurface oceans, the influence of Uranus's unique magnetosphere may provide even more reason to believe they could harbor life. Consider Enceladus, one of Saturn's moons. It has a subsurface ocean, and its interactions with Saturn's magnetosphere create a dynamic environment that scientists believe could support microbial life. What if something similar is happening on the moons of Uranus? If Uranus's magnetosphere allows charged particles from the Sun to penetrate deeper into its system, these particles could be altering the chemistry of the moon's icy shells, potentially heating their interiors and fueling subsurface oceans. The latest discoveries have put Uranus back on NASA's radar. A proposed Uranus orbiter and probe mission in the 2030s aims to explore the planet and its moons in unprecedented detail. This mission could answer some of the biggest questions about Uranus's magnetosphere and its influence on the surrounding environment. One of the mission's primary goals would be to study the planet's magnetosphere in real time. Equipped with advanced magnetometers and plasma sensors, the spacecraft would measure how Uranus's magnetic field changes over time and how it interacts with solar wind. This data could provide crucial insights into the potential habitability of its moons. Additionally, the mission would include a probe designed to plunge into Uranus's atmosphere, gathering information on its temperature, pressure, and chemical composition. This would give scientists their first direct measurements of the ice giant's atmosphere, helping to determine how its unique tilt and magnetosphere shape its climate. But perhaps the most exciting aspect of the mission would be its close study of Uranus's moons. By mapping their surfaces, detecting possible plumes of water vapor, and analyzing their magnetic interactions, scientists could gather the evidence needed to confirm whether these icy worlds are harboring liquid water beneath their surfaces. As our understanding of Uranus evolves, so too does our approach to studying planetary magnetospheres and their effects on habitability. The discovery of Uranus's dynamic magnetic field could reshape how we think about planetary science, not just in our own solar system but in distant star systems as well. If a similar phenomenon occurs on exoplanets with tilted magnetic fields, it could mean that habitable worlds are far more common than we ever imagined. The next few decades could hold even more surprises as we uncover the secrets of this enigmatic ice giant. Uranus may have been overlooked for decades, but its time in the spotlight is finally approaching. The discovery of a shifting, unpredictable magnetosphere, and the possibility that its moons might be affected in ways that support life, marks a new era in space exploration. As humanity sets its sights on the outer solar system, Uranus is no longer just a distant, forgotten world. It is a key to understanding the fundamental forces that shape our universe, and perhaps, a key to finding life beyond Earth. The more we learn, the more we realize that we are just beginning to scratch the surface of what is possible. The mysteries of Uranus are unfolding, and the answers may be more profound than we ever expected. Please like, share, subscribe and comment. Thank you for watching my channel.